All right, here's video 2 of the practice test, helping you get ready for the test tomorrow. Number 12, this is the function f of x equals 6x minus 5 over x squared plus 1. And what you can do for this one is use the quotient rule. This is the top and this is the bottom. The quotient rule here says bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Alright, so the derivative, I'm going to take and write the bottom down exactly as I see it in parentheses, x squared plus 1, and multiply that times the derivative of the top, which happens to be 6. And then minus, I'm going to write the top in parentheses, 6x minus 5, and the derivative of the bottom, which is 2x. All over the bottom squared, which I don't multiply out, I never will. I'll just write it like this. Now I need to simplify the top by getting rid of the parentheses, distributing the 6 here, and the negative 2x here. So this will become 6x squared plus 6. And when I distribute negative 2x times each of these, I get negative 12x squared plus 10x. And the bottom stays exactly as it is. I combine the like terms on the top. And let's see, I'm going to leave the 6 first, and then plus 10x. And then 6x squared minus 12x squared is negative 6x squared all over x squared plus 1 quantity squared. If you really wanted to, you could factor a 2 out of the top, but it's not going to make anything cancel, so you can leave it like that. All right, number 13, this is a tricky one. Okay, so we've got 15 pi cubed minus 120, and some of you are going to look at that and go, oh, that's a power rule problem. And you're absolutely wrong, because pi is a number, and numbers have a derivative of 0. So the derivative here, f prime of x, is 0. The whole thing. That's a number, its derivative is 0. That's a number, its derivative is 0. So the whole derivative is 0. All right, number 14, we've got y equals 2x sine of x minus x squared cosine of x. This is a double product rule problem. This is a product, first times second. This is another product, first times second. I'm using a combination of the product rule and the sum and difference rule. So the first thing I'm going to do is I'm going to use the product rule on this part. So I'll have the first, which is 2x, times the derivative of the second. The derivative of sine is cosine x. Okay, then plus the second, which is sine of x, times the derivative of the first. The derivative of 2x is 2. Okay, that's the product rule on the first part. Now I'm going to use the product rule on the second part, and I have to be careful here because I'm subtracting everything. So I'm going to write minus and then parentheses, okay, and then I'm going to say the x squared is the first and cosine is the second. So the first, which is x squared, times the derivative of cosine, which is negative sine of x, plus the second, which is cosine of x, times the derivative of the first, which is 2x. Okay, then I'm going to clean this up and combine any like terms if I have any. I guess what I notice, if I distribute this negative, this times that whole thing, this times that whole thing, I'm going to have 2x cosine x plus 2 sine of x. That was from the first two. And then I distribute this negative. That is going to become plus x squared sine of x minus 2x cosine of x. And what happens here is this term and this term are alike. So they're going to cancel. And my derivative, f prime of x, is 2 sine of x plus x squared sine of x. And I can leave it. I can factor out a sign. Either way is fine. All right, now let's move on to number 15. Okay, number 15, y equals negative 4, and then the cube root of x minus 7 over x squared. All right, this is a problem where I am going to treat each of these terms separately. This is actually a power rule problem for both parts. If I rewrite my function as y equals negative 4x to the 1/3 power, and then minus 7x to the negative 2 power. Now I can just use the power rule to find the derivative. So if I multiply 4/3 times negative 4, I get 1/3 times negative 4 gives me negative 4/3. And then I take and I subtract 1 from that power, it gives me negative 2/3. Okay, in this term, I'm going to multiply by the power, so that gives me plus 14. Subtract 1 from the power, which gives me negative 3. So now I just have to clean up my derivatives, so I have to get rid of negative power. So in this part, that x to the negative 2/3 is going to go on the bottom with the 3. The negative 4 is going to stay on the top, and I'll have 3x to the 2/3. All right, so then I'm going to take and write this one. The 14 is going to stay on the top, the x cubed on the bottom. And it's not necessary to get a common denominator in a problem like this. All right, now let's take a look at number 16. Number 16, f of x equals negative x times the tangent of x. This is another product rule problem where negative x is the first and tangent is the second. So the derivative, the first, which is negative x, times the derivative of tangent x, which is secant squared x, and then plus the second, which is tangent x, times the derivative of the first, and the derivative of negative x is negative 1. So now I'm just going to make this look a little nicer. It's really only that second term that needs to be cleaned up. That if negative 1 times tangent x just makes it negative tangent x. So I'll have negative x secant squared x minus tangent x. Okay, really the less you try to do with the trig ones, the better. Okay. All right, now let's take a look at number 17. Our function is 5x over x minus 4. And here I'm going to use the quotient rule. So the quotient rule, I'm going to take the bottom, which is x minus 4, times the derivative of the top, which is 5, minus the top, which is 5x, times the derivative of the bottom, which is 1, all over the bottom squared. Then I'm going to simplify the top by distributing and multiplying, so this will become 5x minus 20, and then minus 5x, all over x minus 4 squared. And the 5x and negative 5x cancel, and so my final answer would be negative 20 over x minus 4 squared. All right, number 18. This one looks, again, like a hard problem. It's actually pretty easy. Quotient rule is not necessary. In fact, this is really one of the easiest problems on here. I can think of x to the 6th over 120 is the same as 1 over 120 times x to the 6th. And I can think of this as minus 2/7 times x to the 7th. So this is really just a power rule problem. And so the derivative, if I just use the power rule, 6 times 1 over 120 actually gives me 6 over 120. If I subtract 1 from the power, I get x to the 5th. And then minus, if I multiply by 7, the 7 on top and the 7 on the bottom cancel, and I just get 2x to the 6th. Now one thing I should do here, 6 goes into 120. You can reduce that fraction. So your final derivative should be 1 over 20x to the 5th minus 2x to the 6th. And you can leave it just like that. All right, number 19. The values at which this function, f of x equals x squared plus 3x minus 7, has a horizontal tangent. Horizontal tangent from your notes is where the derivative, f prime of x, equals 0. Or horizontal tangent is where the derivative is equal to 0. So I'm going to find the derivative, and that's 2x plus 3. I'm going to set that equal to 0. It's going to give me x equals negative 3/2. If I want to find a y value, which I need to, the point where it has a horizontal tangent is negative 3/2, comma. If I plug that in there, I get 9/4 plus 9/2 minus 7. So that would be 9/4 plus 18/4 minus 28 over 4. So 9 plus 18 is 27, minus 28 is negative 1/4. So that is the ordered pair on this graph where the tangent is horizontal. Remember, horizontal tangents happen at places like this point right here where there is a maximum or a minimum. All right, number 20, we are asked to find where on the graph of this function x squared plus 3x minus 7 is the slope of the tangent line 0. slope of tangent line equal to, not 0, 4. Okay, where's the slope of the tangent line equal to 4? So we find the slope of the tangent line means the derivative. So where is the derivative equal to 4? Okay, so we take f prime of x, which is 2x plus 3 again. We set it equal to 4. And we solve it. So we subtract 3 and we divide and we get x equals 1/2. And then you could find the y value by plugging 0.5 in here. All right, number 21, if f of x equals 4x minus 4, we want to find the slope of the tangent line. Basically, problems 21 is just asking you to write the equation of the line tangent to the, we are just basically writing a tangent line equation. Okay, tangent line equation at the point 1, 3. That's really 21A and B you're asking for. So I'll just do it all as one problem. So we find y minus y1 equals m times x minus x1. There's my x1 and y1. Okay, I'm then going to plug those in. And to find m, remember to find m in your tangent line, m is slope or f prime of x at the x value. So the m in your tangent line equation is the derivative at that x value, so f prime of x. The derivative of 4x is 4. The derivative of minus x squared is minus 2x. And at x equals 1, you have 4 minus 2, so m is 2. So then I can put 2 in there. And if I distribute and add 3, I get my tangent line equation is y equals 2x plus 1. So there will be one of those on the test. And finally, the last problem. This is if a ball is thrown up into the air with the velocity, so initial velocity is 40 feet per second. Its height in feet after t seconds. We want to find the velocity, position, and velocity functions. Remember the position function, the general position function, s of t, is equal to 1/2 gt squared plus v sub 0 t plus s sub 0 from your notes. And our gravity, since we're in feet per second, g is 32 feet per second squared. So my position function, if I plug in things, let's see, the g would be 32. So half of 32 is negative, it's negative 32. So that'll be negative 16t squared. And then the initial velocity is 40, so plus 40t. And then it says it's thrown into the air, so we're going to assume the initial position is from the ground, so it's 0. So there's our position function. And it says the velocity function, well, remember velocity is the derivative of position. And so the derivative, the velocity function, the other thing part A asks for, would be negative 32t plus 40. So now for part B, it says find the average velocity over the interval from 0.5 to 1. So the average velocity, we're going to take s at 1, the position at time 1, minus the position at 0.5, and divide it by how long the time period was, which is half a second. So if I put 1 into my position function, I get negative 16 plus 40. And if I put 0.5 into my position function, I'm just going to plug it into a calculator here. So negative 16 times 0.5 squared plus 40 times 0.5, and this gives me 16. So to get this, I plug 0.5 into this. All right, over 0.5. So the average velocity, let's see, negative 16 is negative 32 plus 40, which is equal to 8. So 8 divided by 0.5. The average velocity from a half a second to 1 second is 16 feet per second. And it's positive because it's going up still. And then for part C, you just find v of 2. And then part D, you find the derivative, the acceleration function is the derivative of velocity.